Right. Okay, let me share my screen. Unfortunately, I saw too late, that you had done stuff. So right now I'm downloading the container. I hope that doesn't take too long. But
No.
it's
Okay. You might need to do a Cabal update and Cabal build before doing stuff.
Mhm.
Yeah.
Okay, good. So I think the plan is today I go on with the fundamentals. So I want to definitely talk about time, about parameterized contracts, and about minting. And then there are two more topics we want to do, testing and stablecoin, right? As an example. So let's see how far we get today, and then maybe in worst case, we can do the testing and stablecoin on Thursday. I saw you already prepared something for that in the repo, right?
Yes.
What do you know?
Yes. And maybe, we could do testing and stablecoin together because they are not that long. Because they already know quick check and testing in general, so it's not like really new.
Yes, that's good. Right. Okay. Yeah, and then we also wanted to announce, or remind you that the next week, the idea was that you work on your own projects, and then so there won't be lectures, but more like Q&A, or we support your own projects. And of course, you can already get started now, or at least think about what you want to do next week. So just as a reminder, because next week is the last week of this course. Okay, and now it seems while this thing is, I can't do anything, but I can maybe just while I'm waiting for this here to download, which hopefully won't take too long, maybe I can just from the console also look at this from
And
last.
you also
Sorry?
have to explain the time diagram, I think, and stuff, so that maybe, or you're not starting with time.
I wanted to quickly finish last week's example to fix
Oh,
this double spending bug.
right. Yeah, sure. That's actually the homework for the testing lesson, but you can just preview it now.
Or no, if I can also skip that. I explained what one can do, so I
Yeah,
can also if
it's
okay.
there's no need for them to actually do it, but like the homework for the testing lesson is to write the test to catch that vulnerability and then patch it, and to make sure, and use the test to make sure that you actually patch it. But
Okay, that sounds good. Then I can then I don't have to do that. That's even better.
awesome.
Then we can. So where's this time diagram you were mentioning?
When you explain how time works in Bluetooth, you sometimes usually draw this like line.
Yes, yes. Okay,
Yes.
right, right. Okay. Let me just. I don't know. Just open a normal editor. Right. So time and Bluetooth. Um, okay. Obviously, smart contracts are more useful, or one could argue it's necessary that they have a concept of time, because there are obviously things that you want to do that depend on time. But what I mean is that the contract needs to be aware of the current time. And for example, the example I want to do now is vesting. So the idea is that you put some money into a contract, and it can only be unlocked after a certain deadline has been reached. And that's, for example, you could imagine that, I don't know, that Robertino uh, or Karina have a child and want to give them some ADA for their 18th birthday or 21st birthday or whatever. but want to make the gift now, but don't want the children to have access to it before they turn 18, let's say. And then you can do that with smart contract. I mean, that's called vesting. It's also typical in projects where investors get tokens, for example, that they don't get all of them immediately, because then they could sell all of them and that would be bad for the token price. So it's typical in such projects that they get them vested. So they only get a certain amount over a couple of months or years. And that would be another example of why that's useful, this vesting. And of course, you can think of all sorts of real world scenarios where time, deadlines, and so on play a role. There is, however, a problem with that. I explained last time that validation is supposed to be deterministic. So you should be able to, and I also explained these two phases. So there's phase one, in validation. If a node validates a transaction, there are two phases. One is the cheap one. Cheap both, it doesn't cost you anything, but also in times of resources, it's easy to check. And as an example, I said checking that all the inputs to the transaction are still there, that nobody else spent them in the meantime. And then there's the second phase validation where the scripts are executed. And that's expensive, but you never have to actually pay the price for a phase script, because, as I explained, you can do that locally already. So you can execute the script locally. So when you transmit to a local node, the local node already does this, and it doesn't cost you anything, and you already see whether it fails. And a crucial property of this is that is deterministic. So exactly the same will be executed on your local node before you submit as on the blockchain, I mean, by other nodes when they actually validate your transaction. But if you think about it with time, that is a problem. I mean, that seems to be impossible to achieve, because, I mean, naively, you would think that, I mean, if the contract mentions something about time, then in order to say whether I mean, for example, that this can only happen before or after a certain deadline, then I mean, time passes, right? So it could be that the deadline has not yet been reached when you do it locally, but it has been reached when other nodes validate it on the blockchain. So it would no longer be deterministic. It would depend on the current time. And that's bad, because we want this property on Cardano that you can be sure that the second phase validation will always will behave exactly as when you try it locally. So that seems to be a conundrum, how to handle that. And the way Pluto's team, Pluto's is designed to fix that is that the transaction has a so-called validity interval. Both endpoints optional. So that's the time during which the transaction is valid or can be valid. So that is a property of the transaction. So independent of Pluto's for now, transaction has a so-called validity interval where both endpoints are optional. So it doesn't need the start point, it doesn't need an endpoint. So if the start point is missing, it basically starts at the beginning of time. If the endpoint is missing, it ends at the end of eternity. But the validation will only succeed or can only succeed if the current time falls into this interval. And I think by default, both endpoints are missing, so the transaction is always valid. But you can also, using the Cardano CLI, specify one, or I mean the start or the end or both. And now the connection with Plutus is, so during phase one, the node checks that the current time falls into the validity interval. So same as what I said before, that in phase one, you check that all the inputs are still available. the node will also check if there's the current time falls into this validity interval. So if I say my transaction is only valid from, I don't know, from now until tomorrow, 7 o'clock, then the node will check the current time. And if it's after tomorrow, 7 o'clock, it will fail validation. But that's crucially phase one. So the cheap one, the one you don't have to pay for if that fails. And now Plutus scripts only see the validity interval, not the current time. And that gives us back determinism. So if the transaction has a validity interval, that is fixed. When you submit the transaction locally already, when you submit it to your local node, the transaction, you have already equipped the transaction with this validity interval. And the Pluto script has access to that validity interval. And that is independent of the current time. So the Pluto script sees this transaction is valid from then to then and can base its logic on that. But the Pluto script itself doesn't see the current time. So it's only in combination of these two phases of validation that everything works out. Because if the current time does not fall into this validity interval, then phase one validation would already fail. So the script is only run in phase two after phase one has happened. So it has already been established that the current time falls into this interval. So the script knows, the script does not know the current time. All it knows is that the current time falls somehow between the start and the end of this interval. And that is how this seemingly paradox situation is solved, that the Pluto script can still be deterministic, and nevertheless, you get time awareness in your smart contracts. But of course, it means that you don't know exactly what time it is inside the Pluto script. You just know it's somewhere between the end, somewhere falling into this validity interval. And right, so that's the idea. Let me just check how. Okay, that looks good. So it seems it works. So now I need to, the container was initialized. Now let me just do a cabal update. It's irritating. Whatever. Can I do this? I suppose I can.
Okay.
Or I can.
Yeah, the directory is like a servant dependency of. No, I never had that error. Dubious ownership.
It has
You
something to do. It says, yeah.
you can do change own and put your own user.
Yes, that's what I did just now.
Oh yeah, but you are
But
all
it
outside.
seems
But now you're outside. You have to do it inside the
okay. Fine.
and put root.
Oh,
as-
root. Okay.
uh,
Okay. Maybe
no,
I am root.
yeah, you don't need it because you're already root.
Okay.
Okay.
Let's see.
Alright.
Okay. Yeah, that worked.
Awesome. Yeah, that's the thing when you work outside and inside the Docker at the same time.
Yes. The problem is that I think Git only works from outside the Docker. Therefore, sometimes I need to, I'm not sure if you now installed it somewhere inside the container, but until now I always had to, if I wanted to update our GitHub repo, I had to do it from outside the container. And therefore, I
Right.
needed my own ownership. But it's fine. In the worst case, one can switch back and forth.
Yeah, I will check. Maybe can you open a different terminal to see if you have Git at least installed inside
Yeah.
the.
Yes, sure. I think it doesn't know that it's a GitHub repo though, because
Right.
the .git is outside the container. I think
Yeah,
I do have Git installed. It just doesn't. I mean, if I do Git status or something, it says it's not a Git repo
yeah.
because yeah.
I think we are not able to solve that. It's something we have to live with.
Yeah, that's fine. Okay, so that worked. Let me just do a cabal build all. I hope now I don't have to build all the Plutus libraries.
Not sure. Maybe you will, because you don't load the image again.
Yeah, let's see. Anyway, nevertheless, so let's looks very bad. Probably I shouldn't have. Anyway, I'm sure we'll somehow manage. Okay, so I mean, first of all, maybe I should ask whether there are questions to this time thing. Otherwise, we can try to implement a simple vesting contract that is time dependent. Oh yeah, maybe why before we do this, I just go on. I mean, time. Okay, so far so good. So that's how Plutus handles time in the abstract. So now, I mean, what is time, or how is time measured? And unfortunately, that's a bit confusing because time measurement, because the node uses slots. So I mean, Cardano splits time into so-called slots, which happen to be one slot a second right now. And it just starts at slot 0 or 1 with the Genesis block. So by now we are like at a very high number already because it's been going on for, I don't know, 3-4 years. But in principle, that can change. For example, there was the so-called Byron era in the first year or so of Cardano. And there the slot length was 20 seconds. And then for the so-called Shay era, it was in the so-called Shay era, it was then set to 1 slot, 1 second, and it's still 1 second. But that is just a parameter that in principle can be changed. So we don't know exactly what the slot length will be in 1 year or in 5 years. And that is a problem for long-running smart contracts. I mean, normally it's not really a problem because most smart contracts only run for a couple of hours or days. But for example, this vesting example I had earlier, I mean, that was for maybe 18 years or so. If you want to make a gift to a child now that he can use or she in 18 or 21 years. And nobody can say what the Cardano slot length will be in 10 years or even in 1 month. So that would be a problem if you want. I mean, you want to be able to specify times like in real time, not in slot numbers, because you don't know exactly how slot numbers correspond to real time. I mean, at the moment, you know 1 slot, 1 second, but in future it could change. So Plutus in the beginning also used slots, but then like 2 years ago or so, they switched to real time, or rather seconds. I think it's seconds, right? It's not milliseconds. I'm not sure. I never know. Seconds since January 1st, 1970, I think. So that's the so-called Unix era or epoch time. I don't know. I'm sorry? POSIX. Yeah. But POSIX time is because of, do you know, I always forget, is it milliseconds or seconds?
Not sure, but I can check while you explain.
Okay. Anyway, so it's seconds since 1st of January 1970. But I mean, it's seconds. So in your Plutus contracts, you work with time, with real time, or rather the POSIX time, whereas the node uses slots.
In seconds.
So seconds?
Yeah.
Okay, thank you. So the node, and I think last time we saw that Malo uses milliseconds, which is also like weird, but anyway. Right. So somewhere there must be a conversion, because ultimately the validation happens on the node, and the node only understands slots. So when basically the node executes a Plutus program, or Plutus script, it has to provide this context to the Plutus script. And we saw this context contains the inputs to a transaction, outputs, and so on, and also the validity interval. But the validity interval is in slots because it's a node thing. But Plutus, the Plutus script, I mean, in the context, expects it in POSIX time. So the node has to do this translation from slots to POSIX time. And I mean, for what I just said, this is a problem because we don't know what the translation will be in a year, for example. So the node really can't translate that. And I mean, the way Cardano works, you do know for a short time, because I said it's a parameter. The slot length is a parameter and can be changed. But the way these parameters changes work on Cardano is somebody has to make a proposal. So that's like a special transaction or a special certificate on the blockchain. That's a so-called update proposal. And then people have to vote on it. And then if it's accepted, it will eventually be implemented. Or I mean, then all the nodes switch to the new parameters. But built into this mechanism are certain times. So because I mean, you need time, of course, for the votes to come in and so on. So I can't I can't change the parameters from now to in 1 hour. There always needs to pass a certain time for this whole update process. And I always forget, but it's something like 2 hours or so, or even longer, 10 days, I don't know. But it's a couple of days. And that means for a couple of days, the node in the future, the node knows exactly how slots correspond to POSIX time. It's only if we go further into the future, the node doesn't know anymore. And that means it's basically an error to execute a script where the validity interval of the transaction mentions times that are too far in the future. So that does not, I mean, the Pluto script itself can easily work with times that lie years or decades in the future. But the validity of the interval of a transaction, this upper range, or I mean both actually, I think, I mean the times mentioned in the validity interval are only cannot lie too far in the future, because then this conversion would be possible. And that means, for example, in this vesting case, I mean, I can easily write a contract that only unlocks in 20 years, but I couldn't already submit the unlocking transaction now and say, okay, it's only valid, it starts being valid in 20 years, because then the node would reject it and wouldn't be able to do this conversion. So I can only in like 19 years and 11 months or something submit the transaction that actually unlocks when we are close enough to the deadline so that this conversion can happen. Okay, but that's that. So maybe we should. So this is happily building again. Right, but maybe we can start a bit. So I just prepared this file, but I didn't do anything with this. I just copied this atomic file from last time, so that I have all the important stuff. So maybe we can start. Right, so first, how should it work? I'm investing. Let's say only unlocks at a specific time and only for a specific, only when signed by a specific pub key hash. So there are these two parameters to the contract. I mean, we need the deadline and when it unlocks, and we need to specify who is allowed to unlock it. So now the question is, how do we handle these parameters? I mean, obviously, that will be different for each use case. We could, of course, hard code it into the contract itself. But that is obviously bad, because then not ideal, because then every time you want to use it, you would need to recompile the contract and by hand basically edit the source code. So we want to somehow parameterize that. And there are two ways to do this. And one we are already aware of, that's to put it in the datum. So we can put these two parameters in the datum. So maybe we should start with that. So for the last example, I had this atomic datum. So let's call it vesting datum now. Let's call it VD for vesting datum. And we have a like deadline. I'm not sure what's the opposite of deadline. I mean, it's more like a lifeline, because since whatever, I call it anyway, deadline. So that's the time when it unlocks. And there's a type for that, I think it's called POSIX time. But of course, now it's not. So unfortunately, because this is still building, I don't have any editor support. So I'm not completely sure, but I think the type is called this. And then I want, like, for example, beneficiary. And those things should actually be in this Plutus. The Plutus Ledger API. It may be a bit outdated, but I think this time stuff works exactly the same. Just see. Okay, so it's obviously not there. Then it's in Plutus TX. Bit weird. I could look here on GitHub. That's just a bit. Okay, fine. Let's look on Plutus TX. Source.
You can use the search bar to the left.
I always forget. This one.
Yeah, there's another to the left, but it does the same. So I think the one on the left, to the right of the master branch,
Yes.
searches inside where you already are, but I'm not sure. That's the file.
Okay. Okay, so it seems it's not there.
No, but that's only files. If you click top, just a bit to the top. There.
This one?
Yeah. Try that one. That should always work on the entire repository.
Right. Okay. Fine. So it is in Ledger API, but that's good. Okay. Right. So it's in Plutus Ledger API v1 time. Or it is milliseconds, it seems. Didn't you say seconds?
Yes, in the
I think it might be that at some point the comment was wrong, but I'm not sure whether they fixed it in the meantime. Where did you get the information? It's seconds?
From the website I used to convert, Epoch Converter.
Yes.
The number of seconds since January 1st, 1970.
Yeah, but I mean, here in the comment, they say in milliseconds.
Maybe they have like further precision for some reason? No, but that's
Yeah,
not.
whatever.
No, that's not possible. No idea.
I mean, they claim it's milliseconds. I know in the past there was a comment bug basically where they said the one, but actually it was the other. But I hope that they fixed that by now. So I hope it's milliseconds. I mean, we actually Atlas also can do this. Like convert.
I mean the Unix time Wikipedia page, and says that it's in seconds, but in modern computers, sometimes the value is stored with higher granularity.
Right. I mean, I know both is common seconds and milliseconds, but okay, fine. So I think Plutus uses milliseconds. Right. So that's that. And let me see how far we are. And is it called POSIX time? Yes, POSIX time. Okay. So that's in. So probably we have to import this version 1. Let's see. And the beneficiary, so that's so why is that? Okay. I want to look for pub key hash. Okay, so there's a type pub key hash, and that I can use to specify who is allowed to collect the money. Okay, then I want to make it like before, an instance of this data class, or that was this from data and to data. Okay, and now the validator. So let's see. Let's call it make vesting validator. Sorry. I think again, we don't need a redeemer in this case, so that can stay as is. And I can already copy this boilerplate because that will be the same. Just that. Okay. Okay, so that should be fine. So we can concentrate on this. And as I said, so we need to check two conditions. We must check that that the deadline has been reached, and we must check that the beneficiary signed the transaction. So now let's again look at this script context. We must just look at the right one, because they are, I mean, we want version 2, so this one. Okay. Right. And we see for the signature part, we part of the context is this pub key hash list. So that's a list of all the people that have signed the transaction. So in order to check that our beneficiary has signed the transaction, we can check this field. And the way I normally do it, I mean, is to somehow make this, I mean, on a high level, delegate the different things to check to helper functions. So I would do something like deadline reached. And then I would normally also do something like trace if false, deadline reached, deadline not reached. And trace if false, beneficiary signed, beneficiary did not sign. Of course, I have to implement these two now. So I think I explained the trace if false before. So the idea is this must be a Boolean. If it evaluates to true, then the whole thing evaluates to true. If it evaluates to false, the whole thing evaluates to false, but this message is traced. So that can be useful to debug a smart contract. Okay, and now obviously you have to implement those things. This should be vesting validator. Okay, deadline reached. And beneficiary signed. Everything gets slow, probably because of the compilation going on in the background, but hopefully we are almost done.
Lars, if you're talking, we cannot hear you. Lars?
I think,
Yeah, his
yeah,
computer might have crashed or something.
Yes. Okay, again, Lars. Okay.
Oh,
Yes, I can hear you.
oh, amazing, amazing. At some point, yes, I think we lost you.
Yes, it was because of the compilation, I think, but I hope that it's almost done now. I mean, it's already at the Cardano stuff,
Yeah.
so hopefully it will go. Right, so I was just saying that I tend to do this with helper functions. Okay. Okay. And I think for both, we need, if I switch back here, we need this tx info and this tx info. I mean, the script context we get with script context here, tx info, we do get the tx info. So let me define like info, tx info, because I need that in both. Script context, tx info. Oh no, it's already, yeah, but yes, I did it like that. But then in that case, I think it's better to do that explicitly. Right. In this case, because I need it twice. And I think if I do it like this, then I basically call this function twice, which normally isn't the problem. But I mean, in Pluto, those contracts. Oh, yeah, should be good. I hope.
Now we can hear you.
Okay. And I think for some reason it's still refreshed. Not sure.
We can hear it, but with we lost you like for a couple of seconds now and then.
Okay, I think it's still busy somehow building this container, or rather compiling.
Yes.
Just not sure whether it even crashed, but I hope now it should.
Maybe
What's
it's
happening?
it's a bit early, but maybe we can do like the 10-minute pause now while it compiles. Lars? Okay, maybe we lost it for real now. I will try to reach him and tell him that he can stop sharing and compile while we take a 10-minute break. What do you think, Karina?
Yeah, I think it's a good moment to take the break.
Okay.
Yeah. Okay.
On again. So Cardano API is one of the last things. I mean, one of the last heavy hitters. And it's just put a simple model up and Atlas, and then it's just the stuff here in this repo. So that should be fine, hopefully. And I mean, again, this is very annoying, obviously, but I mean, normally you would only have to endure that once per project. The reason I now had to do it again is just with this container because we want to make it easy for you. But normally, I mean, if I don't mess with the container and do it once and wait an hour or so, then it should be good. And then when you develop your project, then it's fine. I mean, this is all cached then. Right. Anyway, so we have these two conditions, so that the deadline has been reached, which is the more interesting one because we're now talking about time, and that the beneficiary has signed. And as I said, for the signing part, let's do that first because it's easier. So we have this here, in the TX info field record, we have this TX info signatories, and that's just a list of pub key hashes, and that's the list of those people that signed the transaction. So yes, we can do that. By the way, Robertino and Karina, I mean, could you do something? I mean, would you also need hours to build stuff, or could you quickly? I mean, I'm just, for an example, I'm just wondering whether I should send money to myself or whether I should, one of you can try to unlock it, basically.
I think I should be able to use it like right away.
Okay, then I would just need to push once I have the code so that you could, I mean, because you need the code, obviously.
Yeah.
Right. But then maybe you can already like prepare a key pair.
Yes. Yes. Give me a second. I'm double checking.
I mean, you can do that in parallel.
Yeah.
Right. Maybe Karina as well, just in case that we
Okay,
can.
yes.
Okay, cool. So fine. So we have this TX info signatories. Okay, it worked. So I'm done now. It built, I think. Right. So let me change here. Let me first go into the on-chain.
So you're doing it then?
I think it's done now. So
Yeah. Perfect.
okay, that's much better. So now, okay, so there I need this import. This is okay. I think this was the wrong way around. So the message comes first. It's frightening how helpless one is without like editor support. Okay. Right. So let's do this beneficiary stuff first. So we must just check that our beneficiary, which we can get from the datum. So vesting datum beneficiary is an element of the list of beneficiaries. So that's tx info beneficiary, no, signatories, sorry, signatories of info. Okay, LM is probably something I also need to from the prelude. So LM is also defined in the Pluto's prelude. So that's that. It just checks, it just goes through this list and checks whether the beneficiary is one of the people that have signed the transaction. Okay, and now for this deadline reach, that's more interesting, of course. So let's see. So this validity interval is called TX info valid range, and it's of type POSIX time range. And now let me see if I import Pluto's TX here in the, and if I ask for information on POSIX. Okay, great. That's probably, I must also import this Bluetooth Ledger API. I think it's in version 1, the time stuff. Time, okay. 6 time range. Then we see that I think there's also, I mean, we could do this explicitly, look at that, but let me just, if I search for that POSIX time range. Right, so that's here, also in version 2. But I think that there was no change between version 1 and 2. So it's a so-called interval. It's an interval of POSIX times. And if we ask for interval, then there is this interval module. And so it's, I mean, there are various ways because, as I said, the ends are optional. So it has all sorts of like special cases of that. But in particular, it has these helper functions to construct intervals and also to check whether a given element is in an interval. Right, and so now what do we want to do? I mean, we want that this vesting only unlocks if so this is what Robertino was talking about earlier, that I always have a diagram. Why can't I make it smaller again? Okay, so now right, so now we have our time interval. So Pluto's only knows that we are somewhere, I mean, that the actual current time is somewhere between these points, as I explained before. So Pluto's doesn't know what the Pluto script doesn't know what the current time is. It only knows that the current time falls somewhere in this interval. Okay, and now we have our deadline. And now the question is, what exactly we need to check? I mean, for example, if we check that the actual deadline was like somewhere here, as an example, right? That would not be good, because I mean the current time. I mean we want to guarantee that the current time is after the deadline. So if we check that the deadline is after this B, the end of the interval, then the current time could be somewhere here, which would be before the deadline. So we could potentially unlock before. So what we actually need to check is that the deadline is earliest at A. Maybe I should to demonstrate. Right, because now we know the current time is somewhere here, and no matter where it is here, it's always after this deadline. So that's what we need to check. And how do we check that? I mean, what that means is that our interval must be contained in this interval, the one that starts at the deadline and goes on forever. So our interval, the one from the transaction, of which we know that the current time falls into here. This interval must be contained in this interval. I mean, it would also be okay if it was like this, for example. Right? We must just know that this interval is contained in that interval. That's exactly the condition. Then we can be guaranteed that the current time, which is in here, is not before the deadline. Okay. And if we look, I mean, there are all sorts of helper functions, and one is called contains. And if we look at the comment, A contains B is true if the interval B is entirely contained in A. So we must check that the validity of the transaction is contained in the interval that starts at the deadline and goes on to infinity. So let's write this. And what is the one that goes on? So, and for that we have this from. So that was called VD deadline, I think. Contains tx info valid range info. Now I have to import this contains, it seems. And this from seems to be in, for whatever reason, is already. Okay, so again, from deadline is this interval. It starts at the deadline and then goes on forever. The tx info valid range is the interval coming from the transaction, and we know our current time is somewhere here. If our current time was outside of this interval, then the first phase of validation would already have failed. So if we check that this one contains that one, then in particular, we can be sure that this one contains the current time, and that exactly means that the current time is after the deadline. I hope that makes sense. Right, and this should be good. So if we reload, why is because I didn't save. So I didn't save. Let's try this again. Okay, good. So now I just have all sorts of redundant inputs. Okay, so that seems to work. So, okay, so now we have the on-chain part. We have the smart contract. So again, it will, in its datum, will have a deadline and a beneficiary. And then reached, sorry, spelling mistake. And then it will check that the deadline has been reached and that the beneficiary has signed. And I delegated that to these two helper functions. in order to check that the beneficiary has signed, I check the list of all signatories to the transaction and check that the beneficiary is one of them. And in order to check that the deadline has been reached, I check that this interval that starts at the deadline contains the validity interval of the transaction. Are there any questions to this?
Not so far.
Okay, good. Right. Okay, so now off-chain. So now we need off-chain code. I just, while I was waiting for the compilation, I mean, I just copied from last week and commented everything, but I started converting already. So let me also here in the REPL go there. Okay, I mean this. So I mean, I already fixed the vesting validator and address. So I just what we did always did. So I take the smart contract validator I just defined and use this conversion to define this Atlas conversion to get an Atlas validator and the address. So now I have that. And now I need something like place vesting. I was just busy with that when the break was over. So let me just so for time, we have Genius yield time that we can use, and if we browse types time, anyway, sorry, we can do it. Look at that in a second. But in particular, I mean, there are convenience methods to, for example, get the current time and stuff. And there is also a way to pass time. So I think it also is in, I think it. So there's this, for example, this ISO 8601 pass. That's this. So that's one format. So that is relatively easy to use time. So maybe, yeah, fine, we can do this. So for example, it has get current time. And it's displayed here now as seconds from 1st of January, blah, 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 but 1970. But I can also use this ease ISO thing to show it. And then it's in this format. So this is now the current time in UTC, basically. And I can also pass. So if I have GY ISO pass, and for if I give it back this string, it's confusing because all the editors behave differently with regards to copy paste. Then I get this time back. So I can specify it like this, which is quite nice. Anyway, so I need the time and I need this beneficiary. And so I can, for example, do a GNC up key hash. Right. So I have the value, the deadline, and the beneficiary. Okay. Look up the address, which is now called vesting address. And in this case, again, I just need one output. I just want to place this output. So the address is the address. The datum I maybe should build before. So let D is vesting datum. Vesting BD deadline is the deadline. Okay, I must convert that, of course. So it's a time. I don't know why I don't have. Maybe I have to reload to get support in the editor. But there is, if we see here time from POSIX, time from Plutus, and time to Plutus. So I can use this time to Plutus to convert this format into the one Plutus expects. And vesting beneficiary. Okay, now I have my support. Is pub key hash to Plutus beneficiary. Okay. So far, so good. So now I can use this datum here. I can use inline datum again. Value is V, no reference script, so that's looking good. So that's to place vesting. And now I always had these IO versions, which I still haven't gotten around to like encapsulating that. Place vesting IO. Okay, we need the config file, we need the key file, we need the value, we need the time. We need the pub key hash. Deadline beneficiary. This is all the same. The only difference is that here now we do place vesting. Deadline beneficiary. Okay, so this is for placing vesting. So now we could try that, but maybe I do the, actually, what else do we need? Obviously to unlock vesting. And optionally also with this atomic last time, I also had the scan function that checks the blockchain for all vestings. I could do that again, but maybe for time reasons, I leave that out and we just check in the blockchain explorer to get the UTXO. So let's just do the unlock vesting. So let me just do something like this. Let's call it unlock vesting, which just needs the reference where the vesting is. Okay, so now we need to get the data. So the redeemer we again didn't use, but datum. So we must somehow look up the datum, and we did that before. Sorry, there was. I always forget there are various ways. Was somewhere in this. Yeah, UTXO datum to get it. Right. So we look at the. First, we need a UTXO. Okay. So, and there's something UTXO add reference. So that gives us a maybe UTXO, but there's, I think, also a prime version, which will just crash if there's none. Right. So that's a UTXO. And then there's UTXO datum prime, which will give me the address, the value, which I don't need, I think, but I need the actual datum. Okay, so I have address, value, datum with UTXO datum. UTXO. So this I don't need. Okay, so now I have my vesting datum and I turn it into a datum. The redeemer is just unit. Now the inputs, so it's not burn validator, it's vesting validator. Datum redeemer. So that should be good. Why do I have it? Because I want to use the primed version. Is there a primed version? I must tell what type that has. So say Testing. Okay. Otherwise, it doesn't know what type I'm using it at. Okay. So given the UTXO ref, I look up the UTXO, and with the UTXO, I look up the datum. This is now of type vesting datum. Then I convert it into a datum, and then I do what I also did last week to create a transaction that does this. However, now there's two things are missing. I mean, if I did it like that, it wouldn't be, even though later in the IO part, I mean, let me do the IO part already. So we only need the TX out ref. Everything is the same. Okay. Right. And it looks as, I mean, there are two things, right? The validity interval and the signature. Now one would think, or I certainly thought, that by signing the transaction, that's fine. So now, I mean, whoever unlocks it signs it, and then that should be good. So the signature should be there. However, it's not. Somehow it's not enough to sign the transaction. You must also explicitly tell the system that this or a specific signature is important for Plutus. So it's not enough to actually sign the transaction. You must also say that you basically when you create the transaction, that you expect the transaction to be signed by a certain party. And there is another constraint for that. So until now we have seen must have input and must have output, but there's also something called must be signed by, I think. Must be signed by, right? And that takes a pub key hash. So it's we must explicitly say that. Okay, and what is this pub key hash? I mean, we could either use our own, or we could use the one from the datum, which should be the same, of course, for it to work. So let's use the one from the datum. So vesting datum BD beneficiary D, but this is now Plutus. So we must key hash from Plutus. Okay, so we must convert it. And this is now a monadic operation. So let me put it up here, because it can fail. As I said last time, all these formats are not 100% compatible. And then I can use this here. So again, I look up the reference, get the UTXO, get datum, extract the pub key hash from as the beneficiary from the datum, convert it to Atlas pub key hash. And then I consume my transaction. Let's say it must consume this UTXO, and it must be signed by the beneficiary. And this is still not all, because if I did it like that, the validity of interval of the transaction would be the whole timeline from the beginning of time to the end of time. And if we look back at our diagram, so the A would be basically all the way to the left, and the B would be infinitely far to the right. And then, or again, the Pluto script only knows the current time is somewhere between those A and B. So if I didn't do anything, if I don't specify an interval, then Plutus wouldn't know when the current time is. So in particular, this check that this interval must contain that interval would fail. So must set an interval somehow. And there are various choices what to do. One, for example, is to set an interval that starts at the current time and goes on to infinity. Alternatively, I could also extract this the deadline from the transaction and have it stuck there. So I'm not really sure what's better. Maybe do that. So deadline, like time from Plutus. Testing that. Why this is a bit strange. Right. And now I can say must, or actually there's something called invalid, is invalid after, is invalid before. So if I say is invalid before deadline, right. And here it expects actually a slot, but now I have a time. So I somehow need to convert that to a slot. And there's also something here, if we look again, I think it's not in time, it's in slot. There's something browse genius yield times slot. Right, there's not. Then it must be in this time thing. Just a second. So what did we have? Current time from POSIX. Sorry, that's in sorry. That's in this TX builder thing. But let me also import that to make it easier, more easily visible. Right. Okay, so there are these slot to begin time, slot to end time, but there must also be the other way around. I mean, we now have a time, we must somehow convert it to a slot. Always forget what that's called. It should be called something. Okay, there's sorry. I mean, this is the wrong way around. But I don't see anything. I'm a bit confused now. It must be possible to. Okay, there's a so-called slot config. Right, and just browse time again. From Plutus time to POSIX. Get current time. Sorry. Slot config has its own thing, right? Right. This is what we want. So, and maybe there's also a, right there. Okay, fine. Now I have it. I didn't search for this E thing. So okay, so in this monad we have the way to convert a time into a slot. And I should mention, I mean, this is all a bit complicated, and the reason is that, I mean, as we discussed before, the time is basically measured in milliseconds, but slots, as we saw, is just 1 second. So you can't faithfully convert time to slots because the one is more than the other. So therefore, there are all these variations with, I mean, basically a time, there's this begin and end always, and this enclosing. So a given time falls into a slot, but so you can basically get the slot that is before that time and the slot that's after the time and the slot that where the time falls into that slot. So that's the one we want. So this enclosing slot from time is good for us. So we can to get the actual as a slot, we can use that. Hang on, sorry, unlock vesting. So we can do this here. So like say slot. So we can do enclosing slot from time prime, and now as time we can use this here. Right. So we look up the deadline from the datum, convert it to Atlas time, and then use this enclosing slot from time to convert it to a slot. And this slot we can use here as an argument to is invalid before. So this will now construct a transaction that is invalid before the slot we computed, which is corresponds to the deadline. However, I think there's a slight problem with that. I think this is not completely correct. So it's better actually to use the current time, because the problem is now, I mean, this is always a bit, I mean, we have the deadline now, but so, I mean, we have this deadline. So now we use this enclosing slot, but maybe the enclosing slot is something like this. Okay. And now we construct a transaction where the validity interval starts at that slot. So the transaction would be valid from this slot onwards. But then the smart contract checks that this interval contains the validity interval. And because of this problem that the slot can start before the actual deadline, like a fraction of a second before, then this check would fail. So, I mean, there are several ways to circumvent that. I mean, we could just use like one slot later, for example. But I think it's actually better to, instead of using the deadline, to just use the current time. So this is an IO operation, but we just saw I think there's also a way to do this from inside. I'm not sure whether the monad is actually aware of the current time. Maybe not. I think it's not. I forgot. So one way would be to pass in the current time. So maybe that's what we do. And then, okay, let's do this. So we just pass it in as a parameter, and then we use that here. And now in my IO operation, I actually look up the current time now get current time, and then I pass that in here. Now I got it. And that's one way to do it. So if we wait until the deadline has passed, like at least a second or so. So I mean, if we don't use the deadline as the begin of the valid, I mean, the problem is the first option was to set this A to the deadline. But the problem is we can't do that because the A is specified in slots and the deadline is specified in seconds. So there's this fuzziness. And that would lead to the effect that we would put the A like slightly before star, and then the check would fail in the smart contract. So, I mean, of course, you could add 10 seconds or something to it, but that's a bit brittle because of slot length and so on. So what I've done now is when I construct this transaction, I look at the actual current time. And I mean, this is of course progressing, and then use the slot corresponding to that. So that means maybe, I mean, if we are exactly at the deadline, it would fail. But if we just wait 10 seconds or so until we are safe past the deadline, then that will work. So that's one way to do it. And now we could try it. And ideally, we would try it. I mean, this is now a bit tricky. So I want to time it that we don't have to wait too long, but also that we can try once when the deadline has not been reached and see that it fails, and then try again when it has been reached and see that it succeeds. So if I push this now, I'll just ugh. Ugh, I hate it. The way to somehow force this. I think not. I mean, I think it's in read only, and I can't save this, unfortunately. So now this is gone, unfortunately. My nice diagram, because there is some stupid swap file from. Anyway, maybe I can draw it again. You wanted to say something?
I'm thinking that if you try to open in another buffer, you get the option to like close the previous one and open it and replace it with that buffer, I think. And you can, if you don't have permit, you can use sudo vim, and then you will have permissions. You already closed it?
Yeah, I think I already closed it.
Oh, okay. Sorry.
So I must just. Now I have this stupid permission problem again. What alone knows why. Okay, fine.
You have the file as an untracked.
I'm sorry?
You still have the file there. So you could open it.
Yeah.
If you
Yes,
want.
but I think the diagram is gone. But
okay.
I just wanted to push this. So do you think I can place a vesting and you can unlock it, or the other way around? Can you do it?
Yes.
I mean, can you try to pull and build whether that works for you?
Let's see. Give me a sec. Yes. Let me. Because I was already making changes.
It's fine, and I can also send it to myself. It's just. Okay, let me, in the meantime, there was this address we were using. Just check in Explorer. Scan. reprod that address. Okay, cool. So they're almost, I mean, there's still 10,000 ADA, and there's this one token that we played with last time. Anyway, so I could now, for example, try to like make a, I'm investing for Robertino. Let me just, I mean, I can already start building this.
I was trying to pre-build the binaries, so you don't have to like do that every time you update the image. So I'm in the middle of like building everything.
Okay, then maybe I can just do it myself. I
mean,
so I can just.
I mean, if some student, that a couple of them, I think Kennedy was the one that was already playing with this. If he's willing to do that, like to unlock it, or some other student that is already, or Karina.
Yes, I declared you didn't push the code yet.
I did push the. I think I did, but I think it's on this. I think it's on this branch still. I'm on this.
Different branch. Okay, correct.
This PPP updated.
Okay.
Right. So if I want to do this now, to place it, what do I have to do? So place vesting IO. So I have to give my key file and, oh no, sorry, what was that? The first was the config file. I can use whatever, blockfrost, then my key. Then the value, where again, now I forgot which way around it is. So value singleton, I think first so let's say leftless, let's say 1,000 ADA, so 1 billion leftless. Now I have to specify the time, and let's just, I played with this format before. Just that was in this window, right? No idea. Let me just do this again. So T get current time, and now GY ISO show T. So that's the format I want. So 2023, 10/16 T. Now, so it's 2 hours to me. So let's say, I don't know, how fast can we do this? 10 past 4. It should be fine, right? So 14, 10, 0, C. I think actually it has an string instance for that. Let's try. And now I would need a pub key hash for the beneficiary. You just use an empty string. So, okay. So I must set overload the strings. Try this again. Right. So it seems to work. It can pass the time. So now I just need a pub key hash of somebody. That's the beneficiary. So Karina, do you have a pub key hash for me?
Yeah, let me just
Could you build it?
still building. Let me just waiting a little bit. And
Is it, do you have to build everything, the whole Pluto stuff?
yes, because I reload my with my Docker file, but I think it's 2 minutes to finish the whole building. Yeah.
Okay, 2 minutes. Okay, that's fine. I think we can wait 2 minutes. So if, yeah. And then you have, but in the meantime, can you send me a pub key hash already?
Yes.
I'm making some changes, so hopefully after the next Docker image update, we don't have to build everything again from scratch.
Okay, that would be cool. Maybe I should, just to be on the safe side, change the deadline to quarter past. Karina, do you have a public key hash?
Yes, but I need to because I have in the different. I was running in the different node, so but me I construct in this moment the other
Oh, okay.
hash. Yeah.
Okay, cool.
You're in pre-prod both.
Yes, I'm in. Oh yeah, I'm in pre-prod. And
Sorry,
yeah.
Karina, your preview?
Yes, because I was running in my local, and now when Lars said that we needed to make the same example, I started the Docker in my computer, so it's for this reason. But it's just
But are you on pre-prod? Because I'm on pre-prod.
Yes, yeah, I was running my node in preview, so I need to construct all the new stuff in the pre-prod, and that's it. Yeah. But
Okay.
if someone have some,
I mean, if
if
it's too much
someone
trouble, I
has,
can.
yeah.
I mean, if it's too much trouble, then I can also just create another key pair and do it here. Maybe just in the meantime, I just can do that. What was it? Address. Keygen. Okay. Okay, just in case. Okay, so now that I have the key, the keys, I can build an address. So I need payment verification key file. And testnet magic 1 out file. Okay. And now how do I get the pub key hash? I also always forget that. That's this. Print the hash of an address key. Key hash. Okay. Payment verification key file. Keys. Key. Out file. Keys. Officially. Pub key hash. Okay. Maybe I just do it myself. Okay, so I created a second user basically with a different pub key hash, sorry, key pair, public key, secret key, created the address from that, and also created the pub key hash from that. And now let's use that one, maybe the easiest. Terminal, other one. Right, where's my, why the, is this now gone? So why don't I have my other terminal anymore? I don't know. All very strange. Hopefully it's still in the history somehow. Of course not. Fine. Do it again. So place vesting, IO, block frost, keys, user as key. Now the amount was value singleton, which means yield Lovelace. 3, 1, 2, 3. Now the time. What's the format? It's 2023. The current. Okay, 2023, 1016 T4, 15. So what's the time now? Okay, let's put it to 15. So 1515 0Z. And now this hash. Now probably it again won't work because I didn't put overloaded strings in, of course. Strings. Right. Okay. Okay, so that hopefully worked. So now I can look at this transaction hash in the Explorer. Not there yet. But in the meantime, I need some funds there because if I want to unlock it, I need some funds to pay for the transaction fees. So let me, no, I don't want to restore. I now generated this address for the beneficiary. Copy. Let me just send some funds there. I mean, just 5 ADA or 10 ADA. Let's say 10 ADA. Okay, and I can also have a second explorer. Pre-prod that address. It's now the beneficiary. The moment 0 ADA. So that should hopefully arrive at some point. You can check whether the transaction in the meantime is visible here. Yes, okay, so that's the one where I placed the vesting. So I paid 1,000 ADA from my wallet and 1,000 ADA to this contract, smart contract address. We look at UTXOs. You see it as output. I mean, it used all sorts of stuff from my wallet. So this is the one to the smart contract. And here we also see maybe now this inspection actually worked. Last time there were some problems. Right. So here we nicely see the data in JSON form, basically. So this is the POSIX time, the deadline, and this is this pub key hash. So that's the deadline, the beneficiary. So that's actually quite nice. And we also see it's the first output, so index 0 of this transaction hash. And let's see whether the 10 ADA arrived yet. Yes. So this is now funded, the address. So now I can try to collect. So this was the, let's try this. So I have unlock vesting IO. So again, config file. Now the key is now the beneficiary. So now I'm the beneficiary. And now I need the transaction, the UTXO ref. So this was the transaction hash, and it was the first output, so index 0. And that's it. And if I now try this, it shouldn't work because the deadline has not been reached. Right. I mean, we don't see the error, but it should be, I mean, we do see it comes from the smart contract. And as we said last time, there should be a way to actually see it. And we also see here in the debug output that this is invalid before is now actually set to something. So that should be the time now. And the reason it failed should be because the deadline has not been reached. So according to my watch, it's still 3 minutes until the deadline has been reached. So hopefully if I try exactly the same thing in 3 minutes, it should work. And that would sort of prove that this time thing worked for this example. And also with the signature then. Okay, so I think is there in the meantime a question I can answer? Yes, well,
Not yet.
I think so far there are no
I
questions.
was muted, sorry. Not yet.
okay, fine. Good. Right, so let's try this, whether it actually works. So whether I can unlock in 3 minutes or so, or in 2 minutes now. And then we can talk about parameterized contract, and then we can talk about minting your own currency. So this should still fail. And of course, it would be good if then actually it succeeds. Why does it succeed now already? Oh, was it the wrong one? Oh, it was place. So now I placed another vesting. Okay, fine. So now there should be two actually, but they have the same deadline. So let me see. So this is now a different transaction hash. Yes. That was now by accident. So I placed another vesting, but should be fine. Okay, that's not arrived yet. Okay. Anyway, so at the moment it should still fail because the time has yet not been reached yet, but it's getting close. Okay, it failed. Now if I wait like 10 more seconds, actually it should succeed. At least according to my watch, now the deadline has been reached. So if I try exactly the same again, although that is not guaranteed, it depends a bit on the block. So I basically have to wait until, right? So this is probably because there hasn't been a block yet. So the time over the current time depends on the current time is actually not the current time, it's the time of the last block. And if the last block was before, I mean, it probably was some seconds before, therefore it still doesn't work. So I must wait until there's a new block that's actually after the deadline. So these things are never with like 100% precision. But hopefully soon. We just keep trying. Let's check whether the other transaction has arrived yet. Yes, so that's there now. Let's hope I can unlock this. Now I don't know whether I made a mistake somewhere or whether there hasn't been any block since quarter past, but I mean, by now it's already more than a minute afterwards. Or maybe I made a mistake with the, hang on. What did I actually? Oh, I think I used, I think I made a mistake. I think I should have used 14 UTC and not 15. So it's only an hour, I think. Because I am 2 hours ahead of UTC, not just 1 hour. So that explains that. So maybe I should, I mean, maybe I can unlock it in an hour. I can try again. But maybe for now, let me just fix this and use 1400. I mean, let me just make sure what's the UTC time. Yes, it's 14. So I made a mistake there. Right. So, okay, let's put it to 1420. So in 3 minutes, let's try this again. Okay. And can open that in the Explorer as well. Okay, doesn't matter. Let me unlock or try to unlock. So now the UTXO ref is different. It's this other transaction now. This one here, #0. So that should fail again because the deadline has not been reached. But now if I wait another minute, this one should unlock. And the other two I can then only unlock, unfortunately, in 1 hour. You don't have to, of course. It's just test ADA. But nevertheless. It is. Okay, so at the moment, 1,000 there. So I can also look at the address of the West contract. So there should be 3 now. 3,000 ADA because I did it 3 times. So those 2 were with the deadline in 1 hour, and this one is with the deadline now. So hopefully I can unlock this one now. So according to my watch, everything now should be possible. But again, the time can be a bit off because it's always the time of the last block, which can still have happened before the deadline. Right, but now we get a different error. And now, right. Because I said it must be valid now, but now it thinks it's still a different time. So this has to do with the last block, I think. So now the script didn't fail, but instead the basically validation failed because it says so basically it says I mean I say the transaction is invalid before this time here that ends on 2829, but according to the note the time is only 2794. So I think this is it. So as soon as there's a new block, it should work. Yeah, it's still this 2794. And we see this one here.
Maybe you can query the tip to see.
Yes, I should. Now.
There you go.
See, now it works. So now this time progress. So that's the time of the last block. So now it's securely later, and now it was submitted finally. Right. So now if we look here, at some point there should be 4 transactions. I think blockchain is still quite far away from high-speed trading.
Yeah.
Certainly need to be patient. Would be every 20 seconds, but as I said, it can sometimes take longer. And then, of course, there's like Cardano scan also has, okay, now, okay, 1,000 have been unlocked. And now if we go to, I think it was this address. So this is the beneficiary that only had 10 ADA. Now he has 1,009 and some. So the difference is the transaction fees for the unlocking transaction, but he successfully unlocked the 1,008. And now in like an hour, I could try again to get the other two that where I used the wrong deadline, where miscalculated with UTC time with 1 hour. Okay, but it works, it seems. So this is, yeah, I think time is important. So I mean, for smart contracts, so often you need some sort of deadline. So yeah, that's how that works on Cardano. So are there any questions? Okay, then I suppose we can have another break. So should we have a short one until past or?
Okay.
Yes.
After that
Okay.
one, we're going to minting or?
I thought parameterized quickly.
Oh, right. Yes, sure. I forgot we didn't cover that. Yeah.
Yes, and then minting, hopefully.
Okay.
Yeah.
Sure.
Okay.
Okay. See
Okay.
you.
Talk to you in 5 minutes. Bye.
Yes.
I think I changed my mind. I think I'll first talk about minting because there the parameterized thing is actually necessary or not. Yeah, it depends how you do it. Maybe it's easier to motivate. So I can do that when I talk about minting. Right. So as we have seen last time, uh, when we talked about script context, there was this this purpose. And the examples of Pluto scripts we have seen so far always use the spending purpose. So that's for validators. So the script is used to determine whether an input to a transaction can be spent. And I really talked about the others, and this rewarding and certifying is not used very often, but minting is often used. So this is where it's about how you can create your own tokens on Cardano. And the idea is, I already mentioned that last time when we tried this atomic swap, tokens on Cardano are identified by 2 byte strings. One is called currency symbol or minting policy. The other one is called token name. So the token name is, and both are byte strings, and the token name is more or less freely, it's completely arbitrary. I mean, you can choose one. The currency symbol or minting policy, however, is the hash of a Pluto script. And the way it works is whenever you, I mean, normally there's the rule on Cardano in the ledger that the transaction, the sum of inputs and the sum of inputs plus transaction fees must equal the sum of outputs. So in other words, a transaction can't create or destroy money, which obviously makes sense. I mean, normally you don't want to create or destroy money. However, with these custom currencies, these custom tokens, that's exactly what you want to do. You want to create new tokens and or burn them, destroy them again. So the idea is that each time you do that, so somebody tries to create a new token or destroy it, burn it, the script corresponding to the currency symbol of the token is executed. So, I mean, earlier we said whenever you try to spend an input that sits at the smart contract address, then during validation, that smart contract is executed and decides whether it's okay to spend this input. So now every time a transaction tries to create or destroy value, the corresponding script for the currency symbol of that value is executed. And again, can either say it's okay or fail. So that's the general idea. And with that, you can have like arbitrary policies on, more or less arbitrary policies on your tokens. I mean, what would be like for example, if you have something like, I mean, for real world fiat money, normally it's central banks that decide, have the right to mint new currency. I mean, whatever the European Central Bank can decide to mint new euros, for example. And so, for example, a useful policy would be that you can only mint if a specific signature is included. So that would correspond to this central bank idea. So you could imagine there's a project on Cardano, and basically the project owner, he has to sign each time new currency is created or destroyed. So, I mean, obviously, if everybody could create or destroy a currency, then it's worthless, right? Because, I mean, everybody can do it, so you can just mint your own. So normally, you don't want to make it completely permissible. Of course, you could also do that. So you could have a minting policy that says everybody can mint and burn. But maybe it's more interesting to have one where somebody has to sign. So let's do that. And let's start by me going back to on-chain and copy vesting to minting. And let me go into the right file. Say add minting. We open that. Rename it. Make that smaller. Change this. Okay. So that's now no longer validate. That's a minting policy. Okay. Right. And so first of all, what's the signature? I mean, we had these, let's call it minting policy. So for validators, we said we have datum, redeemer, and context. Now, what's the signature for minting policies? Datum doesn't make sense because datum, as we have learned, sits at a specific output or input. But when you mint, I mean, minting has nothing to do with a specific input or output. It's a property of the transaction itself. Therefore, these scripts only have redeemer and context. So they have a different signature. And actually, it's again built-in data. So it's built-in data unit. But for the same reasons as with validators, we normally write it like typed and then convert it. So the first thing I should do, if I haven't done so yet, is here in the utilities, they have this wrap validator, and there's also a corresponding one wrap policy. So where the wrap validator had datum and redeemer context pool, now we just have redeemer context pool, no datum. Okay, so that's the first thing. And now let's write one. And I think we don't need a redeemer now. So let's keep it like this. Okay, and now I want to create policy where certain only, or let's say minting and burning should only be allowed if a specific party signs the transaction. Okay, so we could hard code this now. I mean, what I want is to I must just check. We have learned that before in the example with the vesting. So I can just, so I have the redeemer, I have the context, and I just check that the one I'm looking for is an element of tx. What is script context tx info context tx in info signatories. Right. So I just check that a specific party has signed. But what specific party? I mean, I could, of course, hard code that. So I could here, I mean, I could look up this beneficiary Papiersch, for example, and just hard code it there. But obviously, there's silly. I mean, and it's not silly, but I mean, normally it's not very general. So if you want to use the same minting policy for a different party, the different central bank, basically, then you would have to recompile the code. So what we would like is to give a parameter here. So or maybe I should do it in 2 steps. So let me first, I think actually I can hard code that. Just give me a second. I think I should do that in 2 steps. I think a string is also implemented there. So I think I could write something like this. Not sure though. Let's try it. And just see whether that compiles. Maybe I need overloaded strings or something. But I think the Plutus Papiersch does implement it. Let me. Okay, right. So that works. Let's first do it like this. So now I need the unwrapped version. That was minting policy. Okay, so it doesn't have the datum anymore, so the signature is different. And that's this now wrap minting policy make minting policy. Why is that complaining? No, it's wrap. Sorry. What is it called? Wrap policy. Sorry. Okay. Okay, like this. And now the off-chain code. Let's see. So what do we want to do? We want to, let's say, mint or burn a certain amount. So
we have the question that why didn't we need the overloaded string? Pragma?
yes, because we expect, I mean, the signatories is a list of key hashes. So I must write a pub key hash here and not a string. But the Plutus pub key hash implements is string, so I can just specify it as a string if I have overloaded strings activated.
Right.
Otherwise,
so
I would, yeah.
we already
Okay.
had it. That the confusion was that they didn't think we already knew had overloaded string.
Right, for whatever reason we already had. Yeah, I know, because of the debug messages. Because here, for example, this thing here, that's actually not a string, it's a Pluto's built-in string. So for that, I already needed overloaded strings so that I can just write a string literal there. That's why I had it already activated. And then I just copied the file, therefore it was still right. Okay. So now if we want to actually use that, so let's just these things. Okay, so first of all, now it's not a valid. First of all, let's import this. Import qualified minting. Okay. So first of all, now it's not a validator anymore. So let's call it minting policy. So this is now a genius yield. I think it's called minting policy. v2. And there's a minting policy from Plutus, same as there's validator from Plutus. Right, so that's that. Address doesn't make sense. I mean, we don't have addresses for, yeah, doesn't make sense. So that's that. So now basically all we need is like a a way to mint stuff. So so let's call it mint. I don't know. I deleted too much, but doesn't matter. So mint, and let's just say, oh yeah, and the token name. I didn't say anything about the token name now. That means at the moment I can use arbitrary token names. I mean, of course, I could specify in the, maybe, yeah. Let's say okay, sorry. Let me hardcode that. Only allows token name Kenya. Actually, it's a byte string, but sorry. Set x overloaded string. E token name. Plutus x. Import Plutus ledger API v1 value token name. But I think I can do something like Kenya. Yeah, that also has overloaded string. And I mean, a lot of people use it with ASCII, and Plutus also displays it like that. But actually, it's an arbitrary byte string. So there are also use cases to use token names that are not human readable. But let me, in addition, check that. Yeah, that's better actually. I mean, I also want to check that the token name is Kenya. Okay. And how do I do that? So we have this. Right now I didn't look at the context at all. I just checked that the right party has signed. But if I now actually want to know, check the token name, I must know what token name is used. So this transaction tries to mint my token. So, and I must decide, is it okay to mint or not? So I must check which token name it tries to mint and then check it. So let's see, script context. So txinfo. And there we have this file txinfo mint, so which is of type value. So this is all that's minted or burned. Right. So how do we? So now we have this value, but it can be. It can be more. Somebody can mint several different coins in one transaction. So somehow we must pick out the one we are interested in. And so we see that is this map type, which is not the map type we are used to. That's a Bluetooth map type. It's defined in some Bluetooth libraries. And we can, for example, so it's a map from currency symbol to a map from token name to integer. So what we can do is, I mean, somehow we must basically find the entry corresponding to us, to the minting we are doing right now for this token. And that's the first problem, because what is the currency symbol? As I explained before, the currency symbol is the hash of the script. So this minting policy gets compiled, and then the hash of that compiled script is the currency symbol. But how can we refer to this currency symbol in the script itself? I mean, this sounds circular, right? We are writing the script, but which will then determine the currency symbol. But in the script, we want already to know the currency symbol. And that would be tricky. But luckily, we have this purpose, which in this case is minting, and that has the currency symbol. So we can get basically our own hash from the function we are writing right now from this purpose. So I can do something like, sorry. Say currency symbol. So I get the, what's it called? Script context purpose of the context. So if it's minting CS prime, then that's exactly our currency symbol. And if it's something else, I mean, that can't happen because we are minting, but I can just do error, I think. Right. Okay, so that's our currency symbol. So now how do we get the, let's call it something like only Kenya? And actually I should do this properly. I should say something signed, has signature or something. And that's this condition. Okay. And then something like only Kenya, or let's call it correct token name. Okay. And then I do this as before, so I can say trace default signature missing as signature, and trace defaults wrong token name, correct token name. Okay, so this is now interesting, how to figure out the token name. So what can we do? So first of all, we have this script context tx info, which again, because we need it here as well, I should factor that out as I did before. So I should do something like info tx info as script context tx info context, and then I can use it here. I can use it as well. So now I want the tx info mint. So this is now of type value. So what do I do with that? So first again, so this is of type value. So type value, sorry. It's of type value, and the value is a new type. So I can get this. I mean, we could also try whether there is something, but I think there is nothing. We have to do that by hand. We can try to look here for search thing now. Why can't I get to the search bar now? Great. For some reason, the search field is not visible. Anyway, let's just check whether there's a suitable function that we can use, but I think there's not.
Oh, there you go.
Oh, right.
Yeah.
Name. Okay, here's this value type defined. Okay, given a currency symbol and token name, we can figure out how much. Okay, we can get all the symbols, but that's also not what we want. No, I think there's a flattened value is relatively useful. Yeah, that we can use, for example. So I mean, we have this. I mean, this map of maps, which is a bit unwieldy to use. But one way, I mean, one thing we could use that's maybe not a bad idea is to use this flattened value. So given a value, it will give us a list of triples of currency symbol, token name, and integer. And what we want to check is that, I mean, there can be other other tokens minted. We don't care about those. We only care about ours that we are defining now. And what we need to check is that when ours is minted, so each triple that has our currency symbol, that then the token name must be Kenya, for example. Right? So that's one way to do it. So we can do all. We define the condition now. Flatten value. This. I probably have to import that. Have to import all. Have to import the dollar. And have to import the und, the and. Have to import trace price. Okay. Lots of imports, fine. And now this function here, so I get such a triple currency symbol, token name, integer, and must decide whether that's okay. So let's call it F. So that gets a triple currency symbol, token name, integer. So if I don't care about the amount, let's say, and now there are two cases. The currency symbol is ours that we computed here, or it's not. So if it's not, we don't care. I mean, that's another minting policies problem. And if it is ours, then we must check that the token name equals Kenya. Integer also. And what's the problem here now? I think otherwise is also, yeah, right. And the equals. I mean, normally I should probably just include the whole import the whole prelude, but I always find it's better to make it explicit, because then if you don't know where something comes from, you can look it up in the import list. So I think it's fine now. Okay. Okay, so again, I mean, I do two checks. The signature check we have seen in the previous example. And now I want to check that everything I mint or burn of my token has the right token name, namely Kenya. So I first determine my token, and I do that by looking at the script purpose, which will be minting my currency symbol. So that's how I can get my own currency symbol. And then I go over everything that's minted or burned, use this flatten value to convert it into a list of triples. And then I use the all function from the prelude, which checks that the predicate holds for all elements of a list. So I must check all these triples that are minted or burned. So in the case of minting, this integer will be positive. In the case of burning, it will be negative. So I don't care if it's a different token, because then another minting policy is responsible for that. And if it's my token that I'm defining right now, I check that the token name is Kenya. Okay, so that should work. And now on the off-chain side, I want to mint. So so let's say I mean, I don't have to do a value, because I mean it's now just an amount. And actually, I mean it must be something positive. No, actually not. So I can give an integer. So that's what I want to mint or burn, and that should be sufficient. Right, amount. So first I need this pub, I mean my own pub key hash, and I think that's okay. I have own address. Okay, so it's like my address. And now there's something like address to pub key hash that gives me the pub key hash of an address. That can fail because the address could be a script address, then there is no pub key hash. But in my case, because it's my own address, there will be. But nevertheless, pub key hash prime. Okay. Now let me just because this is, let me open a REPL here. And okay, I haven't saved. That's good. So I just want to check whether this also works for the Atlas type. Yes, it does. Okay, I can also use that here. Okay, so now I want to say that my transaction must mint. So there's something called must mint. And I need the mint script, redeemer, the token name, and how much. So first the script. Just a second. I deleted that now. No, I didn't. It's up here. So earlier I used, in order to unlock, I mean, if I wanted a script, I used this in script. But I think there's minting policy to script or something, or script from minting policy from, no, then it's minting policy to script policy to script. So I can give it a minting policy and I get a script. Minting policy. Now the redeemer was this unit redeemer again. So I can do redeemer from this data unit. The token name, I can just also use this, and then the amount. And the amount was a parameter to this. What? Okay, I have the mint script. I have the redeemer. I forgot a bracket there. That explains that. Okay. I want a mint script. What is a mint script? Okay. So I must use this mint script constructor and then just give the minting policy. gy mint script. Okay. Got the argument there, and what did I do here? Okay, fine. Sorry. Okay, this is only for this. Okay, I don't have that, but I do have this own addresses that I must use. And let me just again use the first one. It's a bit quick and dirty. Okay, fine. And right, I haven't made use of the public key hash, and the thing is I must sign the transaction. I mean, that's the same I explained before for the vesting. So if I do it like this, even though later I will sign it anyway, I must explicitly say that as we did before. So as before, I must say must be signed by, and there I can do my public key hash. So that should do it. Now again, I can again copy paste one of these IO things and call it mint. So I just need the amount. Okay, and now here mint amount. Okay, and that should do it, I hope. Oh, I don't need the time anymore. Okay. Let's try it. And I did use the, okay, fine. And I did hard code this genius, sorry, this beneficiary pub key hash. So the config is again as before, but now for the secret key, I must use the beneficiary because that's the one who is public key hash I specified. And now I can say whatever, 1, 2, 3, 4, 5, 6, 7, 8, 9 or something. And hopefully that works. Okay. Some error somewhere. Oh, okay, something fishy is going on. So I'm somewhere using. So it seems I can't use the hard-coded string. It's a bit weird now. Let me just check the on-chain code again. Because I didn't complain here, but that doesn't say anything. Plutus can be weird with this plugin that you only get errors later. So it could be that this is the problem. Or that. Or do you have an idea, Robertino or Karina?
Not sure.
60.
I usually have this function to convert.
Sorry?
I usually have this function. I never run like the string from nowhere. Let me send you how I hardcode stuff.
Okay. How do we send it? In chat here or?
Yes, one second. I'm okay.
So probably hard-coded strings are the problem.
Yeah, I always have issues with that. That's why I have this, but I'm not sure if it's going to work properly, but let's try. One sec, I'm searching for it. On chain.
I mean, this is bad anyway to hard-code it, and I just wanted to use that for didactic purposes.
Yeah.
So then we can also show the proper way.
Yeah, encode. I pass the string to encode UTF-8. And this encode UTF-8 comes from the Brutus prelude.
Ah,
Let's see, I can send it in
okay.
black or it's short, so I could just do it through Zoom.
I think, yeah, in the chat or
Like this, I just pass the encode UTF-8 function.
right.
It should work.
Okay, let's try that. Okay. Let's see whether we have the same problem for the public key hash, but that should then also work actually. Same way, I suppose. Okay, so then I use here, and I suppose the same I must do for the pub key hash.
I'm guessing should work, or at least we can try because we have the constructor. So
Sure, we can try. Probably I have to reload this anyway, because otherwise it doesn't recompile the dependency. No, but that could really be because I must do the same for the pub key hash.
maybe.
Does it work the same way? Is that also? That's anyway wrong, right? It's not encode UTF-8. I mean, don't want to encode UTF-8. I mean, it's like hex.
Right. Do we have something like that in the prelude?
See, there's the prelude now. Probably in Bluetooth TX. Well, not there. I don't know why the stupid search bar disappeared. Wait. Ah, there it was for a second. valued. I think not. There's only encode UTF-8. There are sorts of things. Anyway, I think it's fine because that's stupid anyway to do it like this. So then I just come to what I wanted to do in the first place. Maybe I can leave the token name there because that's fine, I suppose. But at least for the pub key hash, it somehow doesn't work. So what I really want to do is I want to make that a parameter of this whole thing. So I would like to say something like pub key hash here. And then use it there. I mean, and actually, I mean, I could make the token name also a parameter, but let's say just, I mean, I always want to call it Kenya, but I want the pub key hash to be a parameter of this contract. And that's possible, but there is a problem. If I do this like this, and then, okay, fine, there's this make minting policy now. But now I must like type minting policy. Typed. So what I want is then that this is also parameterized. So it shouldn't be hard coded. I should be able to give them a pub key hash. To do this. Right, this is another problem here. We can worry about that in a second. Or maybe we should worry about it now, because now this doesn't anymore, of course, this wrap policy. Because it's a different type now. So we have this wrap policy. Maybe I should call it wrap parameterized policy or something. No, sorry. What do I want? Maybe I should do that by hand now. Let me.
Yeah, you got another parameter for the.
Yeah. Yeah, maybe I can. Sorry. Am I? Say. Okay, now I have it's basically the same as before. No, sorry, that's not what I want, right? No. Sorry. Forget that. That was stupid. I was just confused. No. I mean, this basically I want. Now I'm getting confused. Anyway, I mean, this looks right. I mean, I must apply my public key hash. Then I get something of the right type. I mean, if I apply the pub key hash here, yeah. Actually, no, sorry, what I want is, yeah, anyway. So I get my pub key hash here. So, and if I apply that, then what remains after currying is of the right type, so that should actually work. But
Because of the make minting. Wait.
oh yeah,
You are recursively
yes.
calling. Yeah.
Right. This looks actually good, but that shouldn't work, of course. Let's see what happens if I I mean, it looks as if it works, but this is now a bit distressing that that just works.
I mean, your signal's unsafe, so maybe that's why unself like bypass. Or
Actually, I think
the type is right.
I mean that yeah, the type is right, but it can't possibly work. Let me but I would like to observe that. What happens if I do this now here? Okay, that's clear, of course. I mean, let me first fix these things. Because now this is also, I should call that make minting policy or something. Sorry. As well. And this is now a pub key hash. Pub key hash to Plutus PKH. Right. Right. And this shouldn't work. If that works, I'm very confused. Right. Okay, good. It doesn't. Right. Okay. And now the problem is a template Haskell problem. Because and then this can't possibly work. If we look at that, I mean, now this PKH, the public key is a parameter, but here I'm compiling this thing. But somehow, I mean, this PKH now applied to, I mean, basically at compile time now, or at runtime actually. I mean, it looks up my own public key hash and then wants to construct the minting policy at runtime. So at runtime, but I mean, this here happens at compile time. So obviously, I mean, this can't work because, I mean, if you think about it, I now call this mint IO. So at that point here, I mean, in the context of when I'm running that, actually, it looks up my own public key hash. I mean, I pass it in because I read my secret key file at runtime, and then using that, it computes the public key and then the public key hash. And then it wants to do this. So only at runtime is my public key hash known. So I would only at runtime be able to compile this minting policy. But as we know about template Haskell, that runs at compile time. So this line runs at compile time. And obviously this can't work because at compile time, I don't know what public key hash to put there. And that's why I get this error now. I mean, it looks a bit weird, the error, but that's the reason why I get it. And that seems to be a conundrum. I mean, it seems that can't work because I can't compile this. But what I can do, and let me first get rid of this wrap stuff. So let me call that, I don't know what to call it. So it's so I want something of type PKH, and then the redeemer, and so let's say wrapped minting policy. So it should be of type pub key hash unit, and sorry, pub key hash built-in byte string data. Sorry.
Data.
Yeah, data, built-in data unit. So pub key hash redeemer context. So this check. Right, and I want to, of course, to for my own. So this wrapping thing, I just do this by hand now. So make type minting policy. The pub key hash is fine, and now I must just what I did here in these helper functions. So unsafe from built-in data. So I can save from built-in data the unit thing or the redeemer. Built-in data context. Oh yeah, let me, whatever. It's just a name clash. And the check, what's wrong with the check now? Okay. Okay, fine. So this is this. Okay, so and the problem, as I said, is if I only at runtime supply this public key hash, then this can't work because the compilation happens at compile time. And that seems to be a conundrum. But what I can do is compile this whole thing here. So this whole wrapped minting policy, which is anyway misspelled. But this, of course, now has the wrong type. This is now of type compiled code, pub key hash built-in data, built-in data. But the cool thing is that there's something called apply code. And if we look at the type here, so it takes compiled code of type A to B and compiled code of type A, and then there's also and then gives me maybe compiled code of B. And there's also unsafe. I think I want unsafe, right? Safe apply code. Didn't know that this is a new thing, it seems.
Same as the old way, you have to use unsafe.
Right. So this means I at compile time, compile this whole thing, which still is parameterized. So that is fine because I mean that I know at compile time. It's basically this function here that I'm writing. And then there's a way with this unsafe apply code or apply code to at runtime take a piece of Pluto's code and apply another piece of Pluto's code to it. So now I mean, what's remaining is but it must be Pluto's code. So I must at runtime be able to convert this public key hash into code. And that seems as if it's the same problem because we still need to somehow compile at runtime. We must now at runtime take this public key hash and convert it into code. But there is a type class for that does that. And there's a function lift code that takes like a Haskell value and compiles it on the fly. But I can't use that for my scripts. It doesn't work for all types, but it works for types that implement this lift class. And pub key hash and other types like that happen to implement make lift. And I think you can also derive it again. There's a make lift template Haskell. I can now make lift code PKH. I think I can. And this is maybe not, okay, it's not in scope. Why is that? It's also not in scope. What's the problem there now? Why is that? Sorry. The wrong thing again.
Maybe you have to wrap leaf code and public hash in parentheses.
Maybe.
No. No.
So what is lift code? That's in Plutus TX, right?
Yes. Let's see. Yes, Lotus TX.
There's some, or it takes a version. Okay, it takes an additional argument. So that's a new thing. That we didn't need that before. So what version? Oh, okay. All right, because they're now there. That was the reason why last Monday nothing worked, I think, because of these versions. So I think I must import Plutus Core then. Or is there different? There's a, okay, this one. But I hope that uses the right version then. I mean, default sounds like it uses the default version, which is good, I suppose. And I hope that the option that I now set everything to, okay, now. Right. Remember I told you last time that the problem when first nothing worked was that by default it targets version 110, but the node only understands 100. So I had to add this compiler flag. And this is now exactly, I think, what it wants of me. So I must tell which version of Plutus to target. And I hope that this default one now picks the right one, the one that I configured. Yes. So let's hope this works. So again, the problem, I mean, with the original one is I only know this parameter at runtime. So I can't compile, I can't compile the whole thing at compile time already because I know the parameter only at runtime. So the idea is to compile the whole thing, including parameter, but then of course it has the wrong type. Then this parameter still sits here. So then it's of type pub key hash built in data unit. And now the solution is to do this. So I have something of type pub key hash, a compiled code of pub key hash built in data unit, and then at runtime apply this pub key hash. So to the compiled code of the function, I apply at runtime this pub key hash. But of course, that must be also compiled code. But my pub key hash is just a Haskell pub key hash. But there is this lift code that does that. So it basically at runtime compiles certain types. But I can't always use that, not for validators or bidding policies. There I still have to use the template Haskell. But certain types can be lifted at runtime. And that this lift code does. And hopefully this now works. So now I can clean up a bit. And hopefully it actually works. Okay, let's try. Okay, right. So I can't. So I must specify the version explicitly. It's a bit annoying that it doesn't take whatever. So now I must just find out how to apply this version. So I must let me go back. So now it says there's a version mismatch between these 110 and 100. So it seems I must use lift code. Instead. And now I need something of this type, Bluetooth Core version. And for that, I need to import Bluetooth Core because it's defined in there. So let's do this. Okay. So now the error message should, okay, for some reason not. What's it called? Sorry. Bluetooth Core version. Okay, this is now because the editor is not, doesn't have Bluetooth Core yet. Let's see whether what it says now. Okay.
I think it's only one parameter.
Okay. Let's see what I can do there. Okay. It seems I can just specify them as natural numbers. So hopefully, I mean, I find that honestly a bit weird everything, but fine, whatever. So that should do it, hopefully. Yeah. Okay, at least it compiles, I think. I also find it annoying that the editor doesn't believe me that I want 4. Right. Yes, so this is all new stuff that like a couple of months ago, it worked differently. That's, I mean, Plutus is still under active development, so these things unfortunately happen. Let's try this again. Yeah. Okay. So now that worked. And just to demonstrate, I mean, if I try to run this as user, it should fail because now oh no, it doesn't fail. Sorry. No, I did it differently now. Let's see what that is now. I will now run twice, once as beneficiary and once as user. And let me just go. It's all good, all good. Let's just have that address. That's the beneficiary. And this address, I think that's the smart contract, the vesting contract. I want the user address. Just give me a second. So the user address is this one. Now I explain. So let me the user address. Okay, right now it still only has this UBIT token. And this was the beneficiary that unlocked the vesting earlier. And that one, sorry. no, not this one. This address was the beneficiary that unlocked the vesting earlier. And that now has a token 1, 2, 3, 4, 5, 6, 7, 8, 9. Kenya is the token name. But and I think the same is now true for this user, because I ran it twice for the different users. No, it's not there yet. Now, so it has this UA token from last time, and now also has a Kenya token. And that sounds weird because we said we want to restrict that only like a certain party can mint. But the point is, if we look at the off-chain code, how I did this now. So I now had this, so here, make minting policy. So this now takes a key hash. So it instantiates the parameterized contract with the key hash. I pass it here. And now we see in this code here, I look up my own key hash, and then I parameterize the policy with my own one. So I ran this twice, once for the beneficiary, once for the user. So that means it was run with different pub key hashes here. And that means that the minting policy will be different. Because as I said, the minting policy is the hash of the script. And the script, because now we have a parameter, so there are now two different versions of the script. One where the parameter was the pub key hash of the user, and one where the parameter was the pub key hash of the beneficiary. So now if we look closer this looks, on first glance, it looks the same, right? Both parties have this Kenya token. But if we now click on the Kenya token, then we get token details, and in particular, not sure we can see that, we get this policy ID. So asset name is what I called token name, and this policy ID is what I said is also called currency symbol. If we do the same here for the other user and click on this token, so then, the asset name is Kenya in both cases, but if we look at the token, the policy ID, it's completely different. So I minted two different tokens. And because, now the way we did it now, this key hash that needs to sign is baked into the minting policy. So we use two different pub key hashes, one for the beneficiary, one for the user. So we get two different tokens. They're the same token name, but the policy ID is different. So the user can only mint or burn the one sort, and the beneficiary can only mint or burn the other sort. And they are different tokens. So in a wallet, they would appear as different tokens. And we can see they have different tokens because they are different tokens because the policy ID is different. Of course, I could have done it differently, that in the off-chain code, for example, hard code a specific public key hash of somebody. But in that case, then the transaction would just have failed if the wrong person does it. The way I did it now, basically everybody succeeds. If you run it, you can also mint it. But every person that runs the script will basically mint a different token for his own pub key hash. And I could also burn them again. I could now, for example, burn one. So if I run this again as, for example, the user, and now with minus, I don't know, minus 789. Let's run it with minus 1, 2, 3, 4, 5, 6, 7, 8. So now we have to wait. Forgot which is which. This one. Okay. So now we see the total supply is only, I mean, it's this now, whereas the other one still has, sorry, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I burned tokens again here. And I mean, these Cardano native tokens, they are in almost all regards exactly like ADA. So in particular, you can send them to somebody else, as we saw before, I mean, with this Uber token. So I could now send them around to another wallet or whatever, to wherever. Right, but only this user can mint or burn more or destroy some of the existing ones, and same for the other token. So are there any questions to this?
Not so far.
Okay, I mean, we're almost out of time. I
Yeah.
would have liked to talk about NFTs, but I think the time is not sufficient. Maybe I can just explain the issue.
Yes, and I mean, for the stablecoin example, we need an NFT, so I can.
Okay, okay. Should I mention the idea of NFTs, how it works, or?
Yeah.
Okay, so this now took a while, but I mean, we learned 3 important concepts, and I think that's now you have basically seen the most important concepts of Plutus. So we talked about time handling, we talked about minting policies, and we talked about parameterized contracts. And also, I mean, in this case, I basically was forced to use the parameterized contracts because I was not able to hard code this Kirsch, although I'm sure somehow it's possible to hard code it. But doesn't matter. I mean, I wanted to show how to parameterize anyway. Actually, I mean, we also, for example, so I probably should philosophize a bit about parameterizing. I mean, with the testing contract, I decided to put the deadline and the beneficiary in the datum. I could alternatively also have put them, I mean, use them as parameters, either one parameter or 2 parameters. I mean, deadline and beneficiary, for example, as 2 parameters. And there are always, like always in life, trade-offs when you do that. I mean, for example, what would be the effect? I mean, right now, the way I did it now, there was no parameter. So the script that was constant, didn't depend on a parameter. That means all the vestings, independently of deadline and beneficiary, sit at the same script address. And they are distinguished by their datum. So the deadline beneficiary is included in the datum. If instead I move deadline and beneficiary as parameters and maybe use a trivial datum, just unit for the datum, that's possible, would work the same way. But then for every single choice of deadline beneficiary, I would get a different smart contract and also a different script address. Same as now for the tokens, the Kenya token, I get 2 different tokens depending on the choice of parameter. Whether that's a good or a bad thing is up to debate. I mean, for example, in the case of vesting, I would say it's a bad idea to put the deadline as a parameter, because then, I mean, the beneficiary needs to know the precise deadline in order to figure out the address of the contract, where to even find his vesting. But of course, on the other hand, if somebody, and it's difficult, I mean, you can't, from the address, you can't see what the deadline is. I mean, now it's possible you just look in the blockchain explorer and you can read the deadline and the beneficiary right off there. If you put the deadline into a parameter, then, I mean, it's somehow the hash, I mean, it's implicit, but it's impossible to see. So you can be able to, if I place a vesting with you as beneficiary, you wouldn't be able to, from the contract address or the UTXO, see when you can unlock it. And so I would have to tell you basically, otherwise I mean, you just have to try. I mean, you can try every day to unlock it until finally it unlocks. But I mean, that's a bit. So I think that would be a bad choice. But on the other hand, maybe putting the beneficiary as a parameter is maybe a good idea, because now basically every button using this contract would all sit at the same address. If you make beneficiary a parameter, then basically every beneficiary would have his own address for his personal vesting, which might be a good thing. So there's this trade-off, but often it's, I mean, you can make a choice. Do we want to put it in the parameter or in the datum? Sometimes not, like with minting policies now, we saw, I mean, there is no datum. So I have no choice. I have to put it in a parameter if I don't want to hard code it. Right, let's use the same, the last 10 minutes to briefly talk about NFTs. So an NFT is a token that only exists once, exactly once. I mean, there's this one, I mean, that this Kenya token that I just did, I can at any time mint more tokens, for example, or burn some. So the amount is, I mean, right now, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, many. But I could mint additional ones or burn, and so like there's an, and then of course you get tokens like ADA, where you don't just have one, obviously, you have billions, but it's like a fixed number. Although in the case of ADA, I mean, there is this a monetary expansion. So like every 5 days, some more ADA are added to circulation. But nevertheless, there's so many. But in principle, you can think the amount is fixed. An NFT is a special case where the amount is fixed to 1. And people are crazy about NFTs. I mean, so it's important to have NFTs. So the question is, how would we implement an NFT? And so we basically want to guarantee from the minting policy that there can only be exactly one. And actually what, I mean, there was, before Cardano had Plutus, we had something called, so there's a second way of doing smart contracts on Cardano that's older than Plutus. That's so-called native, native, what's called scripts. And they basically allowed you to do a combination of what we did now for the vesting. So actually the vesting could have been done before Plutus because it was, I mean, you could do a combination of deadlines and required signatures. So native script, you could specify like times when it's can be unlocked and who has to sign, and you could combine these things with logical connectors like and or, and also n of m. So something like you could, for example, specify 5 signatures and say at least 3 of those 5 have to sign. And then you could combine these primitives to more complex ones with and or not and so on, with logical connectors. And back in those days, people did NFTs by using basically this time feature and said, okay, they specify in the native script minting policy that you can only mint until a specific date. And then they minted 1 and let that day pass. And then the minting policy guarantees that after that date, nobody can mint anymore. Or we could do the same in Plutus. I mean, we could basically, what we did for the vesting, I mean, in a similar way, we could write a minting policy that forbids minting after a certain time has passed. I could, for example, say, I can mint this token only until 5 o'clock tomorrow afternoon. And then, I mean, before that time, I can do whatever I like and can mint it happily. But as soon as tomorrow afternoon has passed, no more minting or burning is possible. So I could do that, and then I could mint 1 token today and let tomorrow afternoon 5 o'clock pass, and then I can't mint anymore or any less, so I have an NFT. And that's all very well, and people did that and like sold them and so on. But it's a little bit unsatisfactory because you basically need an explorer to, I mean, the minting policy itself doesn't guarantee there's only one. You have to actually look on an explorer or something. I mean, to see that in the time that minting was allowed, only one was ever minted. Right, so people did that, and one could do that in Plutus as well, of course. Then, of course, you might think I could just specify, I mean, here in the logic, I'm going over these triples and check the token name. And of course, I ignored the amount, but I mean, I could check that that amount is 1. And that sounds good, but that wouldn't work because that would only guarantee in every single transaction in which I do minting, I only mint 1. But I could simply submit more than one of these transactions. So even if every individual transaction only mints one, I could still end up with more than one token. So that also won't do. And actually, it's possible to do this in Plutus to guarantee that there's only exactly one token. And that uses quite a clever trick, namely that all the UTXO references on the Cardano blockchain are unique. So you will, I modulo the fact that, I mean, if you believe that hashing is, I mean, you never get same hash again. So the idea is that every transaction on Cardano is unique. And if you think about it, even, I mean, the transaction always needs inputs. You can't have a transaction with 0 inputs because a transaction, I mean, you could on, like, in theory, in principle, because we have transaction fees, you always need to pay transaction fees. And those transaction fees need to be paid from something. So you always need input. And then it's a simple inductive argument. So if, I mean, I could have an identical transaction again, because even if everything else in the transaction is the same, I send the same amount of money to the same address, for example, the input will be different because once I use an input, it's gone. So for the next transaction, even though the next transaction is very similar, I need to use a different input. And that will make my transaction different. So you can, I mean, it's like an easy mathematical proof by induction that implies that no two transactions on Cardano can ever be the same because they have to use different inputs. And by induction, those inputs cannot be the same. You can't have the same input twice because once you spend it, it's gone. Right. So that means UTXOs on Cardano are unique. And once they are spent, they are spent. And the trick to do NFTs with Plutus is to, in the minting policy, specify basically hard code or use as parameter, for example, a specific UTXO that has to be spent. And then the transaction, the minting policy will check in the script that one of the inputs to this transaction is this specific UTXO given by a specific TX outref. So then in order to mint, and it will check that the quantity is 1 of your NFT, of your token. So then for this to pass, for the minting policy to be happy, it will check that this specific UTXO is spent, which is basically hard-coded or given as a parameter. And okay, so when you on the off-chain side, you must make sure that this specific UTXO is spent. So it should be one that you are allowed to spend, that's in your wallet, for example. And then this minting policy is happy, and it checks that you only mint one token and that this UTXO is spent. And once you have done this minting, the UTXO is sent, so you can never repeat this transaction because now the UTXO is gone. So you can't possibly repeat that and mint another one because now the UTXO is gone. So you can never create another transaction that spends the same UTXO. So that then guarantees that your NFT is really an NFT. So you can do this minting only once, afterwards, never again. And this still has a slight problem because even though that's true, it's hard to see because, I mean, it's you must pass this UTXO that you want to spend as a parameter. And as we just saw in the example with the Kenya token, if you use a different parameter, you end up with a completely different minting policy. So it's hard to see if I give you a minting policy and claim that's a UTXO minting policy, NFT minting policy, it's hard to convince you that I'm not lying. I mean, you could, of course, like compile it and check that you get you indeed end up with this minting policy. But it's nevertheless a bit, I mean, so each time I do this trick, I end up with a different minting policy. And there is a way to make that nicer. So ideally, we would want a minting policy, like a fixed one, where we are guaranteed that every single token with that minting policy is an NFT. And that is also possible. And the idea there is you make use of the redeemer. And in the redeemer, you specify which UTXO you need to spend. And that by itself, of course, would be like useless because then you could like just do several of these minting transactions and each time give a different redeemer. So again, you would end up with many tokens of this policy. So then the trick is to encode this UTXO, this redeemer, in the token name. So the idea is basically the minting policy will look at the redeemer and decode the redeemer as a UTXO ref, check that that UTXO is spent, and check that the token name that you mint, one token you mint, also its name, its byte string name is this UTXO ref, or maybe a shortened version of this UTXO ref. So you can run this again, but then you will end up with a token with the same policy ID, but different token name. So the token name basically corresponds to the UTXO, to the unique UTXO you spent minting this token. And that, in my opinion, is like the best way to do NFTs, because then you have this fixed policy and you know, I mean, you only have to convince the world or yourself once that this is correct. And then you know without thinking, without having to check anything, no Explorer, no nothing, you don't have to compile nothing. If you see a token with this policy ID, you know every existing token with this policy ID is an NFT. So yeah, that's the trick how to do NFTs on Cardano. I don't know what you do, Robertino, for your stable coin, which method you use.
I consume UTXO and I parameterized.
Okay, so you end up with a different minting policy then each time. Right. Yeah, that's fine. Of course, one can do that. Okay, yeah, so that's
it's also because when you're testing, you like generate a bunch of coins with a bunch of like stable coin tokens and stuff like that, and gets a bit annoying if you accumulate. So every time you start from scratch.
Right. Of course, you could also allow arbitrary burning for these tokens. So you insist that you can never mint more than one, but you could allow burning it again so to get to clean up. I just want to say one last thing to NFTs. I mean, one use case for NFTs is, I mean, people go crazy about NFTs. And I mean, the point is the idea, I mean, the beauty of an NFT is, or let's say, one of the reasons or the holy grail of blockchain is to somehow link blockchain to the real world. And I mean, it's no surprise that, I mean, a lot of successful or the first successful projects on blockchain are actually DEXs or something. Because, I mean, a DEX, a decentralized exchange, deals in stuff that's already on the blockchain, like tokens on the blockchain. So you can trade tokens on the blockchain, paying in tokens on the blockchain. So, but it's a bit incestuous. I mean, it's blockchain doing blockchain stuff. Of course, the holy grail, what people want is to make it really useful for humanity, is to link things on the blockchain to real world entities, like, for example, a house. And there's all sorts of problems. I mean, legal problems, regulatory problems, whatever. But technically, the idea is, I mean, they always normally use something like an NFT. So the idea is to have an NFT. So you can be guaranteed this token exists once, and then somehow, and I mean, people have really figured out how to do that. But somehow link that NFT to a real world thing like a house. And then the idea is if you sell the NFT or send the NFT to somebody else, whoever owns the NFT owns the house. And and of course, I mean, one thing that's relatively easy to link is like virtual art, digital art. So, I mean, Cardano has this metadata concept, so you can associate so-called more or less arbitrary metadata to a transaction. And then basically the minting transaction of the NFT, they associate metadata that points to some image on IFPS, for example. And then the idea is whoever owns the NFT has the rights to this piece of art. That's the main thing people do with NFTs. I mean, they sell digital art with it. But, and Robertino on Thursday we will talk about that a lot. There's also, I mean, it's often very useful for technical reasons to NFTs. So they are not valuable by itself. that they can be used as markers. We talked about like state change on the blockchain. I mean, because we don't have mutable state. So all the blockchain does is basically it consumes UTXOs and produces new ones. So often you want to represent state of something, of a contract. I mean, for example, if you want a counter, so you have a UTXO and the datum is a number, and you, with certain transactions, you want to increment that number. I mean, you can't do that because UTXOs are immutable. You can't change the number. So what you can do is you can consume the UTXO and recreate a new one at the same address where the number is in the datum is incremented. That's fine. But the problem then is that at this address, there can be a lot of UTXOs flying around. So how do you know which UTXO corresponds to, I mean, you consume one, I mean, to consume one, you create a new one, but how do you make the link between the consumed one and the new one? If they are like, now they are 99, now they are 105. So how do you know which of the 105 corresponds to like which one that was there before and has been spent? And there often the trick is to use an NFT. So basically you include an NFT in the UTXO you are interested in. And then when you want to make a state update, you consume this one, create a new UTXO, same address, update the data, and including the same NFT. And because this NFT is an NFT, only exists exactly once, this allows you to basically track identity. So you can like, even though the UTXO basically changes, I mean, you consumed it and recreated it at a different UTXO ref, the NFT is still the same. So you can use the NFT as a sort of marker or identity. Yeah, it basically gives identity. It's one way to use NFTs is to give your identity to UTXO. So if UTXOs have a lifetime, if the datum gets updated, so they get consumed and recreated over and over again, obviously then sitting at different UTXO refs. So the UTXO ref is not constant, that changes each time there's a state update. If you make sure in your validator that this NFT is always passed on to the new version, then that's a way to like give identity to a UTXO on the blockchain. So that's a trick or method that's often used, probably also for the stablecoin thing. Right? Or do we use it for something else, Martina?
Yes, I use it to keep track of which UTXO is the oracle.
Right, exactly. Because again, I mean, that's my favorite saying that I think you can't repeat too often. Everybody can, at any time, anybody can send anything anywhere on Cardano. There's no validation whatsoever that checks sending outputs. Outputs are completely arbitrary. You can, I mean, you can do whatever you like. Everybody can send at any time, can send anything everywhere. So you can never rely. I mean, if you find something at an address, you can never rely. I mean, you never know who sent it there, whether it was your own off-chain code or somebody else. So you can never rely, for example, on the fact that the datum has a specific format or whatever. But by using NFTs, if you control the NFT, you can make sure. I mean, you can, for example, only look at UTXOs at a specific address you're interested in that contain a specific NFT, and you know. I mean, you make sure that only like legitimate UTXOs basically have that NFT, and you ignore the other ones. And the others, because they don't have the NFT, can't, no matter what they send there, you just ignore it because you only look for one that contains the NFT. So therefore NFTs are really useful, not just by themselves for art or whatever, but also for technical reasons to allow you to like legitimize UTXOs. So yes, there are lots of use cases. But now we are like 10 minutes over the time. Are there any last questions?
Not so far. So maybe not at all.
Okay, then remember this thing I said in the beginning about next week. So if you're interested in pursuing your own project, I mean, it can be something like you're really interested and passionate about, some problem you want to solve in your own life. But of course, it can also be like a toy project or just something to try something out. So maybe think about it so that we don't lose too much time next week, and then you have like meaningful questions to ask. Okay, and then apart from that, the plan is so now on Thursday, I think Martino will do the lecture, and I think I've said everything I needed to say about Bluetooth in general. I mean, there's other things to say. I maybe haven't seen an example of these reference scripts or reference inputs and of these like staking related scripts, but I think that's fine. I mean, the most important things I believe we have covered. I also didn't have time to talk about Lucid. I suppose you use that, but I think you can explain that on the fly.
Yeah, no problem. And I also use reference scripts, so I can also
okay,
read that.
Okay, perfect. Because I felt that seeing as we have spent so much time on learning Haskell in this course, I should use Atlas. And it was the easiest. But then, yes, we see on Thursday as well how to do it from TypeScript, for example. Okay, and yes, so learn about how to test smart contracts and very cool like example project stablecoin, how you can do an algorithmic stablecoin on Cardano.
And we have a question. So you mentioned week after next is the last session. That's the question.
I think next week is the last week. So we will have the session on Thursday, where there will still be a lecture. Robertino will talk about testing and stablecoin. And then next week we will have like 2 slots again. I mean, our usual slots, but the plan is not to do lectures there, but instead help you with whatever projects you come up with. That's the idea. Okay.
Okay, perfect. Yes.
Okay, then thank you very much, and talk to you on Thursday.
Bye-bye.
Bye-bye.
Bye.
Bye.